start our solutions for our activity or our skills review number 5. I've already highlighted key things in our word problems just so we don't have to read the whole problem. So basically for number 1, they're wanting us to build the equations that we need to solve if we were going to solve how many computer sales, the dollar amount of computer sales and dollar amount of phone sales that he had to make to do these said things. So we're going to look at our variables. Our variables are going to be, I'm going to make X basically it's going to be E instead of writing the whole thing, which is the number of dollars in phone sales. And then I'm going to make Y our F, which is number of dollars in computer sales, which is what our 4% and 10% relate to. That's how I know that is what these variables need to stand for. Now, we are given two equations that we're going to be solving. Basically, he had $700 more in computer sales. So we know 700 plus X, our number of number of dollar amounts, right? That's going to equal our computer sales. Next one, $224. What is that being made up of? That's being made of our commission of phone sales, right? Plus our commission of computer sales. And you don't need to solve it, you just had to make the equation. So that's basically what you're going to be doing with this. It's just getting from a word problem and creating the equations you need. Now on to number 2. Number 2, they're given that Dylan and his children went and they spent $4.60 on bananas and mangoes. And there is a total of 8 bananas and mangoes. So let's do our variables, right? B is going to equal the number of bananas. And M is going to be the number of mangoes. Alright, so that 8 is going to be our B plus M. Basically, our total is, there should be 8 fruits that we're buying. What is that $4.60 representing? Well, that's representing the price of the bananas, which was 60 cents per banana, and 50 cents per mango. And that right there is the 2 equations you're supposed to form out of your, out of this word problem. Now we need to solve how many mangoes and how many bananas. I am going to make this equation at the bottom, the 8 equals B plus M. I'm going to subtract B from both sides and give us 8 minus B equals M. So that means anytime I see an M in the other equation, I just plug in with 8 minus B. So we're going to bring this down to here. We have $4.60 is equaling, our B stays the same. We still have this B plus our 0.5 times 8 minus B. Now let's distribute that side. So 460 stays the same. We are still given our 0.6B plus 0.5 of 8, which is just half of 8 basically, which is 4, minus 0.5 of B. Now let's combine like terms. This 0.6B and negative 0.5B. That is going to give us 0.1B plus 4 and 460. Alright, now we need to subtract 4 from both sides. We have 0.6 equals 0.1 times B. Divided by 0.1, we get B equals 6. And from that 8 equals B plus M, if there are 6 bananas, there must be 2 mangoes. And that's all you needed to solve. Alright, number 3. Number 3 is a little tricky because you're not going to be using typical 2 variables to solve this problem. Basically, we have an high school A and a high school B. And it says later in the problem that you're supposed to do it in terms of T. And that's why I have this of T here, because we're not going to have a Y per se. We're really going to have only an X, or in this case, it's just going to be a T. So, high school A, how do we know their population, right? Well, it tells us they start at 550 students, and then they're going to grow by 65 every year, which is T. B, school B, is going to, they currently have 700, and then they're going to grow by 40 students every year. So that right there is the two equations that you're going to need. They're wanting to find out when A of T is going to equal B of T, or basically when they're going to have the same amount of students. So let's solve that. So we're going to have 550 plus 65T, which is our A, equals our 700 plus 40T. Now I'm just going to do this in one step just because I don't have enough room. But basically we're going to subtract 40T from both sides and then subtract 550 from both sides. You'll see what it's going to become. So basically this crosses out, and then we have a 25T equals a 150. You would do that in two steps, but I just did it in the one because I don't have enough room. Now we're going to divide by 25. T equals 6. So let's plug that in because they don't want the amount of years it's going to take. They want to find out actually how many students that's going to be. So let's plug it in for the first one. 550 plus 65 times 6. And you should be getting a total of 940. And then if you did it with the problem B, you're just going to, you should get the same amount. So there is our answer for number 3. Alright, now number 4. Number 4 is when you're adding matrices. Now, with this one as being B plus A. In this case, you can add these in whatever order you want. A plus B is going to equal B plus A in this situation with matrices. But, however, if you were subtracting, you would not. You would need to do B then A. However, this is an addition problem, so you really just need to add however. Now with matrices, if you remember, when we add these, you are going to add across. Right? So with that, you should get a 2 plus 5, which is 7, a negative 1 plus 2, which is positive 1, and then a negative 5 plus 3, which is a negative 2. And that is all you need to know for that one. Alright, I'm going to do the last matrix problems in the second video, so just I have time to explain it. I will see you in the other video.